Okay, number 46. All right. Okay, number 46 says a pilot set his plane to travel due west at 400 miles per hour, and a wind is blowing towards the northwest at 60 miles per hour that blows the plane off course. Okay, and we want to know the ground speed of the plane, correct to 3 decimal places, and we want to know which direction is the plane traveling, correct to 3 decimal places. Okay, you guys just loved this. Okay, so let's think about a coordinate plane, a coordinate grid, and think about a little bit of a visual about what this guy's doing. Okay, it says he's going due west. Never eat soggy Wheaties. Okay, so if we are going west, 400 miles per hour, right? That is our magnitude. It's going straight west, 400 miles per hour. That's it. There's also a wind that's blowing towards the northwest. So that's like this direction, right? Towards the northwest. You can either draw your vector from here and make that 60, or you can add it from the end of this tip of this arrow. It actually does not matter. Okay, so you can do it from wherever. In my class, a lot of times we were doing it from like wherever this one picked up. It really doesn't matter. You end up with the same thing. It's just to sort of give you a picture of what it looks like. Where am I going to end up? But really, my resultant vector is going to end up all the way out here. Okay, this is going to be my resultant vector. And if you notice, we're going to end up in quadrant 2. Right? So I think my x should be negative and my y should be a positive number when I'm done. Okay, the way that we are going to figure this out is we're going to get our 2 vectors and we're going to add them up, right? Because we've got these 2 vectors. And if I want to get the resultant vector, well, we have to add them up. Let's get vector 1 plus vector 2. So what we need to figure out is, well, what are the actual components of these 2 vectors? Okay, what are the 2 components? So vector 1 was one that was the ground speed of the plane, right? The plane that was going 400 miles per hour. So we know that we're going to use the formula magnitude, cosine, angle, right? And then magnitude, sine, angle. For vector 2, we're going to come back to that angle in just a second. This one, the magnitude was 60 cosine angle, and then 60 sine angle. And this is going to tell us the components of the 2 vectors. Okay, the problem is we have to figure out these angles, right? I don't see anywhere in here where it says a specific angle. So let's go to the 400. Let's go to the one going straight west. When we put things into the calculator, you're always referring to your unit circle. So starting from east and sort of spinning around. So if I'm going straight west, right, think of this as 0, 90, 180, and 270. So that means that the angle measure is 180 degrees. Okay, so this is how we're going to find the components for vector 1. To find the vector for component, or the angle for vector 2, we have to think about what does it say. It says northwest. Now it doesn't say any specific angle, so we are going to take it to its word and assume that it is going exactly in the middle of north and west. So, you know, the number like right between 90 and 180, right, which would be 135. That's going to be our... Now, if you were getting stuck with that, there's a few strategies we talked about in class. You could, you know, it's got to be exactly in the middle, right? You know that this is kind of breaking this up into 45-degree segments, right? So you could take 180 and subtract 45. You could do 90 and add 45. You could add 90 and 180 up and divide them by 2. There's lots of different ways you could do that. Okay, but we're going to now get those components. Okay, let me just make sure I am still in degree mode. All right, so I'm going to do 400 cosine of 180, and I get negative 400, which makes sense to me because it goes off to the left, and that's an x-coordinate. And then, let's see, hopefully you guys have a guess what this one's going to be. This one's going to tell me the y-coordinate, or the height, which was 0, right? Think about that. If I went straight west, I didn't increase you know, horizontally at all. Okay, plus, now we're going to do the other one, 60. We're going to get some different numbers on this one because we're going at an angle, more of an angle. Negative 42, 426. And then, and I'm not going to be surprised if I see a similar number here because I'm going, you know, halfway through. I think my number is going to be the same thing but positive, and it is. Okay, so my resultant vector, which is this guy, right? The components of that are going to be these guys added up. So let's say this is going to be negative 442.426. And then the y's added up will just be whatever this one is, 42.426. Okay, wonderful. We just found out tons of information, but you know what? We still haven't answered our questions. But we had to do all of this work just to get to the question part. What is the ground speed of the plane? Okay, ground speed in this case is talking about our magnitude. Okay, it's talking about our magnitude. I want to know what is the magnitude of my resultant vector. So once I know this, I can now find its magnitude by squaring them both and taking the square root. Okay, so I'm going to do negative 442.426, close it up, square it, and then 42.426, square it. Okay, and I'm going to take the square root of that answer. 444.456 miles per hour. This is the ground speed. So this is part A. Okay, and that actually makes sense to me. We know that it was the plane itself was going 400 miles per hour, but if the wind is moving in the same direction, it's working with it, not against it, it's actually going to make it go faster. Think about running or something like that, right? If you're running with the wind, it's going to move you along quicker. If you're running against the wind, it's going to make you run slower. Okay, so then now we want to know, well, what is the direction of the plane? Okay, well, let's think about this for a second. Let me get a color I haven't used. Okay, when I go my inverse tan, which is in your formula sheet, right, and I'm going to put the y coordinate over the x coordinate, everything's going to go in positive. It's going to tell me this little tiny angle right here. Okay, we are going to answer it as referring to the from east. So, you know, we'll kind of look at it both ways and go from there. Okay, so I'm going to go inverse tan. And then I'm going to put in the y coordinate divided by the positive x coordinate. .478 degrees. So that would be the number of degrees like north of west, if that makes sense. North. Right? Just north, it goes up 5.4 degrees up from the west direction. Now we talked about putting it in just standard like from east, right? So like, you know, if you're just, you would assume 180 minus 5.478, and this would be your sort of your standard degree that we referred to. 174.522. And you could just say degrees, right? If you're going to stick with this one, you have to be very specific. 5 degrees where, you know. If you just say 174, you're going to assume that you're starting east and working your way around. Okay. All right, we'll try maybe a couple more here. All right, for 4748, we're going to write the series using a summation notation. All right, awesome. Okay, this is our summation notation. This should be pretty familiar. This is the last unit that we did. This symbol here is a sigma. It's a Greek letter for S, for sum. Okay, and there's 3 pieces that we need to fill in for our sigma notation. Okay, the bottom one tells us how many, what term we're going to start with. And since I'm given a list, right, we're going to be starting with term 1, which is almost always going to be the case. Sorry about that. There was an announcement. I couldn't think. Okay, so the bottom number here tells me, which term number am I beginning with. The top number up here is going to tell me where am I going to end. Well, if you see this ellipse here, these 3 dots, right? Sometimes there's a number after it, and you would have to figure out what term number is that. But in this case, there's nothing there, which means that this is going to go on for infinity. So we're writing an infinite sum here. All right, now the question is, what is this rule? All right, we have to look at the pattern here and see if we can write out a rule. Is it an arithmetic rule? Is it a geometric rule? Maybe it's neither one. And when I look at this, it looks to me like those numbers are doing what? It looks like they are going times 2, doesn't it? Okay, that means this is geometric. Okay, and a geometric rule, this is not given, so you'll have to know it. Looks like this. First term, rate, n minus 1 power. Okay, and you're just going to have to know that. You're going to have to be able to write that on your own without a formula sheet. So first term is 8. It's multiplying by 2 to the n minus 1 power. Now, how can I know that this is right? It's pretty, and you can't use a calculator for this, but it's still pretty easy to check without a calculator. Let's say, for example, I want to know the second term. I want to check to make sure my second term works. I can plug in 8 times 2, plug in 2 for n. This makes 8 times 2 to the first power. That's 8 times 2, which is 16, right? And that was my second term, so it works. So make sure if you write a rule, make sure you actually go back and make sure that it actually works each time. Okay, we're going to do the same thing with this one. This one looks like an adding pattern, and this one has an end, right? There's no ellipse there at the end saying, hey, I'm going to go on and on. So I'm going to write sum. Since I'm given a list, I know I'm starting with term 1, but I need to figure out what term this one is. So it looks like I go to term 7, so 7 goes on the top. This one is an adding pattern. You can probably tell pretty quickly. This is adding 4 each time. So this one is an arithmetic. Okay, and our rule for arithmetic, which again you're not given, is first term plus n minus 1 times that common difference. So for this one, I would start at 11, n minus 1, and the common difference is 4. So you can simplify that if you want to. It's certainly not required, especially but you can, and some of you may have come up with a different rule that might be equivalent. So let me just show you, if you decide to simplify this a little bit, or maybe you said, hey, I came up with a different answer and I'm not sure if it's right or if it's working. Do you see how I just distributed the 4 here? So I get this, and then you can collect your 11 minus 4, 10, 9, 8, 7. Sorry, I haven't had all my coffee. So this would also be a perfectly acceptable rule to have right here. They're equivalent, so it wouldn't matter which one is which. And that one's it. All right, so